This is the third video of circular motion. Here we are going to discuss about some problems based on hands-off clock. We know that in a clock we have three hands. One is hour hand, and this is the minutes hand, and here is a second hand. So first we should know about the time period of these three hands. What is time period? Time taken for one complete revolution of this hour hand is 12 hours. It takes 12 hours to complete one circle. So let's change it into seconds. So 60 multiplied by 60. For the minutes, it will take 60 minutes to complete one rotation, one revolution. So we can write here 60 minutes change into seconds. For the second hand, it will take 60 seconds. So no conversion. So we are going to find the angular speed, angular displacement, angular acceleration, everything. So these are all the basic formulas here. We have already discussed in the previous videos. So let's explore few problems based on this. The first problem here, you can see, calculate the angular speed of second, minute and hour hand of a clock. So for hour hand, the time period is here. And now we are going to find the angular speed. So for the angular speed, the formula is omega for the hour hand is equal to 2 pi divided by time period for hour. So you can put all the values 3.14 divided by 12 times 60 times 60 is equal to 1.454 times 10 to the power 4 minus 4 radian per second. This 2 pi, unit of 2 pi is radian and unit of time period is second, so radian per second. You can write like this also. Now we found for hour hand. Now we can find for the minutes. So the same omega minutes is equal to 2 pi by time period of minutes. So 2 times 3.14 divided by, for the minutes, it will take 60 times 60 seconds. So the answer is 1.746 times 10 to the power minus 3 radian per second. Now we found for the minutes and the last second. So the same 2 pi by time period. This is for the time period for the second hand. So 2 times 3.14 divided by 60. This answer 0.105 radian per second. So these values we are going to use for the further calculations for the angular speed of hour, minutes and second. These three values are important. Okay, now we can discuss the another concept. Second question, what is the angular velocity of the minute hand of a clock? We know that minute hand omega is equal to 2 pi by time period of minute hand is equal to, we already have learned, 1.746 times 10 to the power minus 3 radian per second. What is the angular displacement of the minute hand in 20 for the 20 minutes? So this is the second. First question is over. So angular displacement is theta is equal to omega multiplied by time. So what is here omega? This is the angular velocity 2 pi by time period for the minutes hand multiplied by the time for 20 minutes. So we know this value 2 pi by this value is here. So 1.746 times 10 to the power minus 3 multiply by 20 minutes. We have to convert it into seconds. Otherwise, you cannot give per radian per second. It will be radian per minute. So here, the answer for this 2.095 radiant. If this 60 is not there, so what will happen? What is the unit of this? Radian per second. And this one seconds. So second and second power minus 1 will be cancelled and here will be radiant. Otherwise it will not be matched. So we have to convert minutes into seconds in order to get the unit radiant. Now the third question is there. If you see, if the minute hand is 5 centimeter long, 5 centimeter long, so we have to go back and check the picture. This length is 5 centimeter, which means if it goes in a circle, so this length of seconds, sorry, not a minute hand, second hand, the length of seconds hand will be the radius of the circle. And here we are discussing for the minutes hand and the length is given 5 centimeter. So the radius of the minute hand is 5 centimeter, right? So we are going to find what is the linear velocity. That is the third question. Linear velocity V is equal to R omega. What is R here? The radius of a minute hand, that is 5 centimeter. Centimeter has to be converted into meter. So centi 10 to the power minus 2 multiply by omega. Omega for minute hand is constant. It's always constant. We already found. So if you multiply, you will get 8.73 times 10 to the power negative 5 meter per second. Let's see the third question. What is the angular displacement of minute hand of a clock 25 minutes in 25 minutes? So here we know angular displacement formula theta is equal to omega t, and already we know the omega for minute hand is 2 pi by this value 2 times 3.14 over 60 times 60 for minutes, right? So what is the value? 1.746 1.746 multiplied by 10 to the power minus 3 radian per second. So we have to write the value here 1.746 10 to the power minus 3 and 25 minutes. Time is here 25 minutes. So change into seconds, multiply by 60. The answer is 2.618 radian. For the angular displacement, the unit of angular displacement is radian. So let's see the question number 4. The extremity of the hour hand of a clock moves 1 over 20th as fast as the minute hand. So the velocity of hour hand is 1 over 20th of velocity of minute hand. This is what the question says. 1 over 20th of as fast as a minute hand. What is the length of the hour hand? The length of the hour hand is the radius. Actually, the length of every hand is the radius of the particular hand. So we have to find RH, that is the length of our hand. If the minute hand is, so the minute hand is 10 centimeter, so 10 to the power minus 2 meter. We have to convert centimeter to meter. So centi 10 to the power minus 2. So this is our target that we have to find. So we know here the VH, that is the velocity for the linear velocity. We are going to find the linear velocity of the our hand is equal to 1/20th times as fast as minutes hand. So we know the formula of linear velocity is equal to r omega. So that we are going to substitute here. R omega is equal to 1 over 20 r omega. This is for the hour hand. So here h. So this is for the minutes. So right here minutes. Now it is easy. Later, now we have to find RH. So I keep RH here, and this will be the denominator. So 1 over 20th r minute omega minute divided by omega for the r. So this will be like this, 1 over 20. What is the minute hands radius? 10 to the power 10 times 10 to the power minus 2. So omega per minute. Omega for the minute we already know, 1.745 multiplied by 10 to the power minus 3 divided by for the hour. So we can check the values. 1.454 1.454 times 10 to the power minus 5 or 4. I have to check. Minus 4. Minus 4. So if we simplify, we get 0.06 meters, which is equal to 0.06 meter. If I want to change into centimeter divided by 100, so it will be 6 centimeter is the radius or the length of the hour hand. So this is the answer. Question number 5. The length of an hour hand of a wristwatch is 1.5 centimeter. So the length is known as a radius of an hour hand is 1.5 centimeter. So we can change into meter, 10 to the power minus 2 meters. Find the magnitude of the following with respect to time. With respect to tip of the hour hand, that is the angular velocity. We have to find the angular velocity. We found it. That is, the formula is 2 pi by time taken for one complete revolution for the hour hand. So 2 pi divided by, it will take 12 hours, 60 times 60. The answer is 1.454 times 10 to the power minus 4 radian per second. Okay, next linear velocity. So the linear velocity formula is v is equal to r omega. The radius of the hand is 1.5 10 to the power minus 2. The length of the our hand is the radius. We know this already. Multiply by the velocity, angular velocity 1.454 times 10 to the power minus 4. So the answer is 2.181 times 10 to the power minus 6 meter per second. This is the linear velocity. Now we are going to find the angular acceleration. Angular acceleration alpha is equal to 0 because in a uniform circular motion, angular acceleration is 0. Now we have the radial acceleration. What is radial acceleration? Now suppose here is a point, the particle, and it is moving around the circumference of the circle, and any object which is moving in a circular path need a centripetal force, and the force is always acting toward the center of the circle, and centripetal due to centripetal force there will be the centripetal acceleration. So the centripetal acceleration is acting towards the radius. So this acceleration name is a radial acceleration or centripetal acceleration. The formula is v square divided by r. So the velocity we have v, linear velocity, is 2.181 times 10 to the power minus 6 whole square divided by the radius. Radius is here 1.5 centimeter, so minus 2. So the answer is 3.2 multiplied by 10 to the power minus 10 unit meter per second square. So this is the answer for radial acceleration. We found the radial acceleration AR. The next, tangential acceleration. Tangential acceleration, if you want to find, you have to draw that tangent here. So as the speed uniform circular motion, the linear speed is uniform, magnitude is constant, so the no change in the velocity, so acceleration, tangential acceleration will be 0. Angular acceleration, at the same time the tangential acceleration is 0. So we found tangential. Now the linear acceleration. Linear acceleration formula is a is equal to square root of tangential acceleration square plus radial acceleration square. This tangential acceleration is 0 plus radial acceleration square is here 3.2 times 10 to the power minus 10 whole square. So our answer is 3.2 10 to the power minus 10 meter per second square. Thus we have found the answers of all. What if the uniform circular motion is not constant? Which means here is a particle moving in a circular path, and here is a center, and centripetal force is acting. If the draw the the tangent, here the speed changes continuously. speed increases. As the speed increases, acceleration also changes. There is an acceleration. The acceleration is not zero, no longer zero if the tangential or the linear speed is changing. So in this case, how are we going to find? So first we have to find the acceleration, tangential acceleration, that is at, tangential acceleration. The formula is change in velocity over time. That is a linear motion acceleration formula. So that is the first question. 1200 kilogram car accelerates from rest. So the initial speed is 0 meter per second. To a speed of 40 meter per second, the final V is equal to 40 meter per second, and it increases its speed within 5 seconds at a constant rate on a circular track of radius of the track is 800 meters. First we are finding the tangential acceleration, change in velocity, that is final minus initial divided by time. Final speed is 40 minus initial speed divided by time. So 40 divided by 5 is equal to 8 meter per second square. Second question, what is the centripetal acceleration? So centripetal acceleration, that is the radial acceleration, is equal to v squared divided by r. So in the place of speed, it will be 40 square divided by the radius of the track is 800. So here is 1600 divided by 800 is equal to 2 meter per second square. That is the centripetal acceleration. Now calculate the net acceleration. So net acceleration, square root of tangential acceleration square plus centripetal acceleration square. So tangential acceleration is 8 square, centripetal acceleration is 2 square, will be 8.25 meter per second square. Now we found net acceleration. The last question, what is the net force acting on the car? Now according to Newton's second law, F is equal to mass times acceleration. If it is the net acceleration, the total mass multiplied by net acceleration for to find the net force. If we want to find the net force, we need net acceleration. So the total mass of a car is 1200 multiplied by the net acceleration is 8.25. The answer is 9900 Newton. In the next video, we are going to discuss about problems based on Earth and problem based on rotating disk. Thank you very much for watching my video.